This is USMLE QA. USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is the regulation of glycolysis? Answer: the regulation of glycolysis is controlled by a variety of enzymes and molecules, including glucose and glucose 6-phosphate. Question: what are the key enzymes in glycolysis? Answer: the key enzymes in glycolysis include hexokinase or glucokinase, phosphofructokinase 1, phosphoglycerate kinase, and pyruvate kinase. Question: what are the reactants of the enzyme hexokinase in glycolysis? Answer: the reactant of the enzyme hexokinase in glycolysis is glucose 6-phosphate. Question: what are the reactants of the enzyme glucokinase in glycolysis? Answer: the reactant of the enzyme glucokinase in glycolysis is fructose 6-phosphate. Question: what are the activators of the enzyme phosphofructokinase 1 in glycolysis? Answer: the activators of the enzyme phosphofructokinase 1 in glycolysis include AMP and fructose 2,6-bisphosphate. Question: what are the inhibitors of the enzyme phosphofructokinase 1 in glycolysis? Answer: the inhibitors of the enzyme phosphofructokinase 1 in glycolysis include citrate. Question: what is the rate-limiting step of glycolysis? Answer: the rate-limiting step of glycolysis is the reaction catalyzed by phosphofructokinase 1. Question: what is the product of the enzyme phosphoglycerate kinase in glycolysis? Answer: the product of the enzyme phosphoglycerate kinase in glycolysis is 1,3-BPG and 3-PG. Question: what are the reactants of the enzyme pyruvate kinase in glycolysis? Answer: the reactant of the enzyme pyruvate kinase in glycolysis is Phosphoenolpyruvate. Question: what are the inhibitors of the enzyme pyruvate kinase in glycolysis? Answer: the inhibitors of the enzyme pyruvate kinase in glycolysis include fructose 1,6-bisphosphate, alanine, and glucagon. Question: how does glucose 6-phosphate enter glycolysis? Answer: glucose 6-phosphate enters glycolysis through the action of the enzyme hexokinase or glucokinase, which phosphorylates glucose to form glucose 6-phosphate. Question: how is fructose 6-phosphate converted to glucose 6-phosphate? Answer: fructose 6-phosphate is converted to glucose 6-phosphate through the action of the enzyme glucokinase, which phosphorylates fructose 6-phosphate to form glucose 6-phosphate. Question: how does phosphofructokinase 1 control the rate of glycolysis? Answer: phosphofructokinase 1 controls the rate of glycolysis by acting as the rate-limiting step in the pathway, meaning that its activity determines the rate at which glucose is converted to pyruvate. The activity of phosphofructokinase 1 is regulated by both activators and inhibitors, including AMP and fructose 2,6-bisphosphate, and ATP and citrate respectively. Question: what is the role of phosphoglycerate kinase in glycolysis? Answer: phosphoglycerate kinase plays a crucial role in glycolysis by catalyzing the transfer of a phosphate group from 1,3-bisphosphoglycerate to ADP, forming ATP and 3-phosphoglycerate. Question: what is the role of pyruvate kinase in glycolysis? Answer: pyruvate kinase plays a crucial role in glycolysis by catalyzing the transfer of a phosphate group from Phosphoenolpyruvate to ADP, forming ATP and pyruvate. Question: what is the role of alanine in the regulation of pyruvate kinase? Answer: alanine can act as an inhibitor of the enzyme pyruvate kinase, which regulates the rate of glycolysis. When alanine levels are high, pyruvate kinase activity is decreased, slowing the rate of glycolysis. Question: how does glucagon regulate glycolysis? Answer: glucagon is a hormone that regulates glycolysis by inhibiting the activity of the enzyme pyruvate kinase, which slows the rate of glycolysis. This occurs in response to low blood sugar levels, as glucagon signals the body to increase glucose production. Question: how does AMP regulate the activity of phosphofructokinase 1? Answer: AMP regulates the activity of phosphofructokinase 1 by binding to the enzyme and activating it. This increases the rate of glycolysis as more glucose is converted to pyruvate. Question: how does fructose 2,6-bisphosphate regulate the activity of phosphofructokinase 1? Answer: fructose 2,6-bisphosphate regulates the activity of phosphofructokinase 1 by binding to the enzyme and activating it. This increases the rate of glycolysis as more glucose is converted to pyruvate. Question: How does citrate regulate the activity of phosphofructokinase 1? Answer: citrate regulates the activity of phosphofructokinase 1 by binding to the enzyme and inhibiting it. This decreases the rate of glycolysis as less glucose is converted to pyruvate. Question: how does ATP regulate the activity of phosphofructokinase 1? Answer: ATP regulates the activity of phosphofructokinase 1 by binding to the enzyme and inhibiting it. This decreases the rate of glycolysis as less glucose is converted to pyruvate. Question: how does fructose 1,6-bisphosphate regulate the activity of pyruvate kinase? Answer: fructose 1,6-bisphosphate regulates the activity of pyruvate kinase by binding to the enzyme and inhibiting it. This decreases the rate of glycolysis as less glucose is converted to pyruvate. Question: how is the overall rate of glycolysis controlled? Answer: the overall rate of glycolysis is controlled by a combination of enzymes and regulatory molecules, including hexokinase or glucokinase, phosphofructokinase 1, phosphoglycerate kinase, and pyruvate kinase, as well as molecules such as fructose 2,6-bisphosphate, citrate, alanine, and glucagon. These molecules work together to control the rate of glucose conversion to pyruvate and ultimately the rate of ATP production.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the First Aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.